Thank you. Not as much math as it is logic and English. And so this section is a good example of that. We're learning about conditional statements. And conditional statements are just if-then statements. So as an example, in the book I think they used if the weather is nice, then I'll wash the car. This is a conditional statement. One depends on the other. Okay, so one thing you have to know how to do with this section is identify what the hypothesis is and what the conclusion is. The hypothesis always follows the word if. It does not include the word if. So if I ask you for the hypothesis of this statement, what's the hypothesis? Doesn't include the word if. So the weather is nice. The hypothesis is the weather is nice. Hypothesis. Come on, board. Hypothesis is weather is nice. What's the conclusion?
I'll wash the car.
Yep. The conclusion, I'm just going to, for the sake of time, conclusion is here. I'll wash the car. Okay? If you saw a statement that said, I'll wash the car if the weather is nice, what's the hypothesis?
The weather is nice.
The weather is nice. So don't think the hypothesis always comes first. The key is the hypothesis always follows the word if. And you notice that there's not a word then in what I just said. I'll wash the car if the weather's nice. I'll wash the car is still the conclusion. Everybody clear with that?
Yep.
Okay, so not real complicated. Just don't put the word if when you're writing it, or then. It's always what follows. Hypothesis follows the word if. Conclusion follows the word then. Okay. What we also learned in this section is the hypothesis is always the letter P, and the conclusion is always the letter Q. So I could say that P is the weather is nice, and Q is I'll wash the car, and I would represent that this way. If P, then Q. That's how we replace fragments of these sentences with letters. The hypothesis is always P. The conclusion is always Q. And I always make this arrow, and then when I read that, this means if P, then Q. If P is that, if the weather is nice, then I'll wash the car. Okay? So once we have if P, then Q written, there's three other things you need to know. This would be your original conditional statement. You need to know what a converse, an inverse, and a contrapositive is. And if after the reading and the video you're still unsure, you need to know that for a quiz. You've got to know what the converse, the inverse, and the contrapositive is. And so for me to explain what those are, I need to show you one more symbol. And it's this. That symbol means not. The opposite of whatever it is. Not. Okay? So, this is my original statement. To get the converse, I switch Q and P. So this conditional statement now reads, if I wash the car, then the weather is nice. Everybody follow? The converse just switches the original hypothesis and the conclusion, and they become the hypothesis and the conclusion. They switch. Okay? The inverse maybe. Inverse, come on board. I can't write very well with the mouse. Okay, the inverse, let's see if it picked my pen back up. I put the word not, or the symbol not, in front of the original. Don't switch them. Leave them the way the original is. I just put the word not in front of them. So this would read, if the weather is not nice, then I won't wash the car. I just negate the original statement. Does that make sense? If the weather is not nice, then I don't wash the car. That's what that squiggly means, is not. Okay? And then the last one is called the contrapositive. Okay? And it says you switch them and make them not. So it's basically the inverse of the converse. I know that's kind of confusing. But I use the converse, but I make them not. So this would read, if I don't wash the car, then the weather is not nice, or isn't nice. Okay, so on a quiz, I may give you a conditional statement, and I'm going to ask you, what's the inverse? Or I'm going to ask you, what's the contrapositive? Or I'm going to ask you, what's the converse? So you must know the difference between the converse, the inverse, and the contrapositive to be successful on a quiz. So if you're still unsure, go back and read the textbook, watch the video, whatever you need to do to get that in your head. But that's how I would characterize it with P's and Q's. P is always the hypothesis, Q is always the conclusion. Okay? The last piece of this section is something called a biconditional statement. And a biconditional statement says, if I'm given P then Q, oh, come on. Q then P is also true. If I'm given P then Q, Q then P is also true. That's a biconditional. And I write it this way with double arrows. As an example, if two angles equal 180, then they are supplementary. Everybody agree that's true? If two angles added together equal 180, sorry, that's mine, then they are supplementary. What if I said the converse? If two angles are supplementary, then they equal 180. Is that true? Yes. So it's a biconditional statement. It works both ways, and they're both true. Okay? If I go back to my original, if the weather is nice, then I'll wash the car. If we assume that's true, could I say, if I wash the car, the weather is nice? It's not necessarily true. I could think of counterexamples to that. Okay, if the weather is nice, then I'll wash my car. So we're going to say that's true. If the sun is out, I'm going to wash the car if it's nice. Does that mean that I can't wash the car anytime? No. So the converse isn't necessarily true. So that wouldn't be a biconditional. The regular statement and the converse must be true for a biconditional statement to exist. There's a chance on NWEA and even on ACT, they may ask you about a biconditional statement, and just know it works both ways. That's the biconditional. One condition leads to the other, and the converse is also true. A lot of definitions in this section, really not a lot of math, but it's all logic, which is part of proofs, which we're going to get into at the end of this chapter. Okay? So the key points here, understand hypothesis follows if, conclusion follows then, no matter the order, so it's not always first and second. Hypothesis is represented by the letter P, conclusion is represented by the letter Q. If I write a P then Q statement, there's always an arrow pointing toward the Q. You must know the converse is them flipped, Q then P. The inverse is the original statement made not, so not P then not Q. And the contrapositive is basically the inverse of the converse, which is not Q then not P. And given a sentence, you need to be able to identify the converse, the contrapositive, the inverse. Your homework on CK12 or your classroom problems will have problems like that to give you practice on how to do that. So hopefully that'll help keep the definitions square in your head. Okay? Questions on 2.1 from yesterday? That's due tonight. 2.2 CK12 and classroom problems will be due tomorrow night. Right now I have a quiz planned for tomorrow on 2.1 and 2.2. Why don't we postpone that since we kind of have a shortened day, and I'll give you some extra class time tomorrow to keep working on 2.2. Okay? And we'll plan the quiz then on Monday. All right, that's it.